Good morning, students. We are studying the chapter atoms and molecules. Now we have learned the two laws, that is the law of conservation of mass and the law of constant motion. So now we have learned all these laws, two laws. Now we will study the Dalton's theory of atom. We know that the first scientist who discovered atom was the actually Indian philosopher Dalton. But later on the name was given to the Dalton. Then Dalton discovered atom. So when the Dalton discovered atom, he gave his theory. And there are some points related to the Dalton's theory of atom. Dalton's atomic theory. The first part is, this is Dalton's atomic theory. Dalton's atomic theory. So according to this theory, the first point is every metal is made up of very small particles called atom. So the first point of the theory is every metal, either it is liquid or gases or solid. So every metal is made up of particles, the smallest particle is called atom. So the first part is every metal is made up of very small particles called atom. So I think you understand the meaning of this statement. It means either this chalk, it is also made up of particles, and the smaller particle by which this chalk is made up of is called atom. Now we know that atoms combine with each other to form a molecule or a compound, and we know that this chalk is made up of, actually this is calcium carbonate, CaCO3. Okay, we will study lots of formula in this chapter. So the first point is every metal made up of very small particles called atom. Second is atoms cannot be divided. So according to Dalton, he said that atoms cannot be divided. So at the time of Dalton, it was thought that the atom cannot be further divided. It means this is the smallest particles. If we are going to divide any metal, the smallest particle we get after the further division is the atom. So according to him, he said that atoms cannot be divided. The third point is atom can neither be created nor be destroyed. So he says that atoms can neither be created nor be destroyed. As we study in physics, that the energy can neither be created nor be destroyed, can be converted from the one form to another form. So same as, according to him, atoms can neither be created nor be destroyed. It means if we have, suppose we have coal, and we know that coal is made up of lots of carbon atoms. So these carbon atoms cannot be created, cannot be destroyed. Okay, the one question which can be in your mind, if we burn this coal, it converts into carbon dioxide. Then what's about the carbon? This carbon atom will not get destroyed. They react with oxygen to form carbon dioxide. When coal react with oxygen, it forms carbon dioxide. So here this atom is not going to be destroyed. It's formed another molecule. So according to Dalton theory, he says that atom can neither be created nor be destroyed. Fourth point, atoms are of various kinds. It means as there is a kind of elements, as there is a kind of atoms. Now more than 118 elements has been discovered. More than structure, same mass, same density. It means the atom of same kind of elements are same, are identical in all aspects. In mass, in shape, size. So all the elements, all the atoms of same elements are identical in all aspects. So this is another point. Now, Dalton's Swift atom is very important and you should learn it. Next point is atoms of different elements are different in every aspect. So, atoms of different element are different. What is the meaning of the sentence? It means that suppose we have some carbon atom, this is a carbon atom, and we have some sodium atom. So according to him, these atoms are different in every aspect. Like they have a different mass, they have a different shape, size. Okay. So according to the Dalton, he says that different elements have the different atoms, and they are different in all the aspects like mass, size, shape, etc. Next step. When atoms chemically combine together, they form a molecule or a compound. Atoms combine chemically to form molecule or compound. Compounds. Okay. So when atoms chemically combine, they form compound. In this chapter, we will study the structures of molecules, also the bonding between the molecules, between the atoms, the bonding between the atoms. So when we study about the bonding of atoms, then we will understand the meaning of this sentence. It means atoms chemically combine to form the molecule. Either they share electron or they remove or gain electron for the formation of a compound. So we can say atoms chemically combine to form a molecule or a compound. Suppose the hydrogen atom and oxygen atom. When they combine together, they form what? A molecule. So atoms combine chemically to form the molecules or compound. Next is the number and kind of atom in a compound is fixed. The number and kind of atom in compound is fixed. So for example, if we take the example of water molecule. We know that this water molecule always contains the two elements, that is hydrogen and oxygen, and they always combine the same ratio, that is 2:1. It means in water molecules will always have two atoms of hydrogen. Now the next point is, during a chemical combination, different atoms combine in a small whole number to form a compound. Atoms combine in small whole number to form a compound. Atoms combine in small whole number to form a compound. What is the meaning of this sentence? It means that, suppose we know that water molecules, what is the formula for the water? It is H2O. Here we know that two atoms of hydrogen combined with one atom of oxygen. So can it possible that we combine half molecule of oxygen with one molecule of hydrogen? elements of same kind can combine in more than one ratio. Can combine in more than one ratio to form a compound. It means that suppose carbon react with oxygen, it can form carbon dioxide where the ratio between the atoms of carbon and oxygen is 1:2. Either they can form carbon monoxide, that is CO. So here 1 atom of oxygen combined with 1 atom of carbon. So it means 2 or more elements can combine in more than one ratio to form a compound. So these are few points of Dalton's theory. Now we have done the 2 laws. Law of chemical combination. First law, according to the first law, the matter cannot be created nor be destroyed. Yeah, we can see in a chemical reaction, the total mass of reactant is always equal to the total mass of product. So can we explain this law on the basis of the Dalton's theory? Yes. According to Dalton, Dalton says that atoms cannot be created nor be destroyed. So if atoms cannot be created, cannot be destroyed, so if in a chemical reaction, the atom combine to form a new compound, since the atoms are not destroying, it means the number of atoms before the reaction is always equal to the number of atoms after the reaction. So it means that the mass or total mass of all the atoms of the reactant should be equal to the total mass of all the atoms of the product. Sorry for this type of disturbance. So okay, for example, we are going to heat calcium carbonate. I take this example. I took this example in last video. So we have a calcium carbonate and we heat this one. We get calcium oxide and carbon dioxide. Here we know that the number of calcium 1 is here and 1 is also here. So if we follow the Dalton's theory, so according to Dalton's theory, he said that the atom can neither be created nor be destroyed. It means the number of atoms in the reactant should be equal to the number of atoms in the product. Like for example, carbon. There is 1 carbon, also there is a 1 carbon. And what about the oxygen? The number of oxygen is 3 and here also 3. So according to Dalton, he said that the atom cannot be created nor be destroyed. It means the number of atoms, the total number of atoms in a reactant, number and kind of atom in the reactant should always be equal to the number and kind of atom in a product. So we can say that matter cannot be created nor be destroyed. Or in a chemical reaction, the total mass of the reactant is always equal to the total mass of product. Now the second law. According to the second law, that was the law of chemical combination. Atoms chemically combine to form a compound in a fixed ratio. They always combine in a fixed ratio to form a compound. So how can we relate with the Dalton's theory? According to Dalton's theory, he said that, yes, he said that atoms combine chemically to form a compound, a molecular compound. So yes, we know that according to the constant proportion, the atoms chemically combine to form a compound. Yes, this is correct. And they always combine in a fixed ratio to form a compound. We can understand by taking this theory. Number and kind of atoms in a compound is fixed. So if the number and the kind of atoms are fixed in a compound, then we can say, suppose that is an example of water. So according to Dalton, he said that the number and the kind of atoms. It means the number of atoms is 2 in water molecule, hydrogen atom are 2 in a water molecule, and oxygen atoms are only 1 in water molecule. So according to Dalton, he said that the number and the kind of atoms. It means the number of hydrogen atoms is 2. It should always be 2, and oxygen is 1. So according to his theory, the number of atoms will be same. And the kind of atoms, it means if we are taking hydrogen and oxygen in the water molecule, it cannot be changed. We can't take carbon in the place of hydrogen. The number and the kind of atom in a compound is fixed. So we can say the atoms are always combined in a constant proportion to form a constant ratio to form a compound. Yeah, we can say that the mass of hydrogen is always fixed. This one. 2 hydrogen having the mass 2. Oxygen always having the mass 16. So the mass of hydrogen is 2 here and oxygen is 16. 1 ratio 8, the ratio of their mass. Since the number and the kind of atoms are not changing, so the ratio of their mass cannot be changed. So it means we can understand both the laws on the basis of Dalton's theory. Yeah, Dalton's theory was really appreciated because he was the first scientist who discovered about the atoms, said few points about the atoms. Now, again there is some drawback with Dalton's theory. So now we are discussing the drawback of Dalton. So let's discuss the drawback of Dalton theory. Though his theory was mostly very acceptable, but there is some drawback in his theory which he can't explain, which he could not explain. So, first one. Okay, I think I should draw this board for explanation. So, there is some drawback in Dalton's theory. Out of this drawback, they are discussing only the 3 drawbacks. So, this is the drawback of Dalton theory. First drawback was, according to Dalton's, atoms can neither be created nor be destroyed. Dalton said that atoms cannot be created nor be destroyed. Yeah, it was correct actually. The drawback was, Dalton said that the atoms are cannot be divided. Yes, the theory, he said that atoms are not divisible. He said that atoms cannot be divided. But now we know that atoms are made up of 3 fundamental particles called electron, proton and neutron. So, the theory that atom cannot be divided further was proved wrong. The first drawback was, according to Dalton, he said that atoms cannot be divided. But we know that atom is made up of 3 fundamental particles called electron, proton and neutron. But atoms are made up of 3 fundamental particles called electron, proton and neutron. So this was the first point of Dalton's drawback of Dalton theory. Now the second point, Dalton said that the atoms of the same elements are identical in every aspect, like the mass, the size and the chemical reactions. But it was disproved when isotopes was discovered. Isotopes or isotopes. So let me explain you what are the isotopes. Isotopes are those elements, those atoms which having the same atomic mass but different atomic mass is different but the atomic number is same. Or we can say the atoms which having the same chemical properties. The atoms which having the same chemical properties but having the different mass are called isotopes. Again I am telling you, isotopes are those elements which having the same chemical properties, or we can say the same atomic mass but different mass number. They have a different atomic mass. For example, hydrogen. Hydrogen has 2 isotopes, 3 isotopes actually, all having the number 1 but having the mass 1, 2 and 3. These are called protium, deuterium and tritium. So isotopes, though they are of same atom, that is of hydrogen, but their mass is different. So as Dalton said that the atom of the same element should be identical in every respect, but it was wrong in case of isotopes. Isotopes having the same chemical properties, or we can say having the same atomic number but having the different mass number. So you can see according to Dalton, atom of same elements, are identical, isn't it? But isotopes are of the same element which have a different mass number. But isotopes of an element having same chemical properties, but different mass number, atomic mass, same chemical properties but different atomic mass. So he did not explain how the same element can have a different mass number, because according to him all the elements in the same atoms or the atoms of the all the atoms of the same element should be identical. So these are the two drawbacks. And the third drawback, isobars. I know you did not ever listen this word isobars. So now I am going to explain isobars. Isobars are those elements which having the same mass number but different atomic number. Potassium, it should be argon. Argon and calcium. It means both the elements having the different chemical properties, but their mass number is same. These are called the isobars. Isobars having the different atomic number, so they have the different chemical properties, but same mass number. So according to Dalton, he said that different atoms having different properties. They are different in all aspects. So different elements are different. The atoms of different elements. We should write it. He said that atoms of different elements are different. But in case of isobars, are those elements, are those atoms having same mass number, having same atomic mass, but different chemical properties. Atomic mass but different or we can say different atomic number. So these are the drawback of dotted theory, and he was not able to explain the drawback of this theory. So in next video we will understand the size of the atom and the symbols of different atoms. We know that it represents hydrogen by H, carbon by C, calcium by Ca, sodium by Na. So how we find out this? Yeah, who was a scientist who showed that by which symbol